All right, good afternoon. Welcome, everybody. Thank you, first of all, for being here and spending part of your SIGGRAPH Asia with us here today. My name is Neil Trevett. My day job's at NVIDIA. I'm here as president of the Khronos group. And this is the Khronos Fast Forward, where we have a brief 60 minutes to tell you about everything interesting that's happening at Khronos. So it's going to be very fast paced. And we hope to have time at the end for Q&A. Store up your good questions for any of the speakers that we're going to be hearing from today. We're very fortunate we have the chair of Vulkan here, Ralph from Samsung, chair of the Slang working group, Shannon from NVIDIA, and OpenXR. A lot of work going on at PICO. So you have Jian here who's going to give us a good update on OpenXR. Everything else that's not in those three, I'm going to try and cover in 30 minutes, and then we'll get into the Q&A. So if you haven't met the Khronos group before, we're an open standards consortium. We focus on low-level APIs to access GPU and XR and AI hardware acceleration. We are a global standards organization. We have about 150 member companies. Any company is welcome to join. All of the standards that we create are open and royalty-free for the industry to use. This is the most active standards that we have in development right now. They group into 3D graphics, things like Vulkan and now Slang, ANARI, WebGL that we'll be talking about in this session. Parallel compute APIs like OpenCL. We don't normally cover those so much at SIGGRAPH, but we'll briefly mention them here today around AI. Spatial computing, XR with OpenXR, and the Khronos API, which we'll briefly mention again, and then glTF and 3D asset formats. We also have some safety critical APIs for embedded and automotive markets. But this is SIGGRAPH, so it's kind of more interesting to figure out how these APIs get used in a typical spatial computing application. I've used XR as an example here, where you have a camera looking at the scene, and we have the Khronos camera API. Then you want to do vision and inferencing, perhaps, and we have a bunch of compute APIs. You want to control your XR hardware, and that's what OpenXR is for. And then we have the family of APIs and languages for 3D graphics and the glTF file format for feeding assets into those APIs. So let me start by just spending a minute on the Khronos API, because we don't have a standalone BOF for it, but just to let people know that it exists. The Khronos has been asked for quite a few years now to do an open standard embedded camera API, because embedded systems, there are a bunch more sensors being used in autonomous devices and vehicles of various shapes and sizes, different sensor types, higher performance, and the need to feed good sensor streams into downstream processing is getting more and more acute. So there's a real need for a camera open standard API, because there is no open standard camera API in existence in the industry right now for this embedded kind of application. And so everyone is using proprietary APIs. A lot of the time, the functionality of cameras is hidden below the API. And so it's become a real bottleneck to innovation in using vision processing. So the Khronos API is an API that's in development. We haven't released it yet. It's one of our newer working groups, and it's intended to cover the ISP, the camera sensor, and the whole camera module, the lens, the sensor, and the ISP processing that's close to the sensor. We hope to have first draft specification in 2025, next upcoming year. So if you're into cameras and would like us to help us develop this API, please get involved. The next one along in the pipeline is compute, and of course the hot topic of the day is AI and machine learning. We often get asked, what is Khronos doing for AI? A lot of low-level acceleration is the answer. So if you look at the broad machine learning landscape, we have the well-known frameworks on the left, and very often they run on CPUs. But if you want to use hardware acceleration, there's a set of APIs there. There's proprietary APIs, there's open standard APIs, the Khronos open standard APIs at the bottom. If you want to do inferencing, the picture gets a lot more complicated, and there'll be a test on this slide at the end of the presentation. A whole set of engines, compilers, and runtimes that integrate in various ways into the frameworks and then call various runtime APIs. You can tell from the density of the work, people connecting runtimes and frameworks together. There's a lot of work and investment going into AI. It's a very dynamic and fluid market right now, which means potentially it's too early to standardize some things. But having this middle layer lets you optimize the acceleration and customize it for your devices and your markets. So given the complexity of that, I think that the value of the open standard APIs becomes clearer. You may want to use open standard APIs if you want to run your inferencing, for example, on multiple hardware platforms. You can save quite a lot of development effort. And all the APIs that are being used for inferencing acceleration are from the Khronos group. This is actually most vividly shown in the embedded machine learning market. A whole set of embedded chip vendors. They all have their own compilers or runtimes. Very often they want to do offload into their silicon. And so in the embedded space, OpenCL and actually OpenVX, which is another Khronos API, are the APIs of choice, with Vulkan becoming more interesting, I think, to a bunch of silicon vendors that have GPUs as well as embedded silicon. So the best way to summarize what is Khronos doing about machine learning is that we're having lots of active debates inside the group and with the larger industry on what should we do. And some of the active questions are is it better to have intermediate runtimes, or are compilers better, or are we going to end up with both? Do we want high-level acceleration APIs or low-level acceleration APIs, and what functionality should they include? How can we best provide good tensor acceleration? Do we need to gather around a tensor definition like ARM's TOSA proposal, for example? How can we provide acceleration not just for CPUs and GPUs, but for NPUs and TPUs? What should the APIs do to enable that diversity of silicon? And if you are running on a programmable processor like a GPU, how do you load balance the machine learning and inferencing load along with the other loads that you want to run on your GPU? So these are all interesting questions, and these are all being debated inside the various working groups inside Khronos right now. So again, if you want to get involved, please, you'll be welcome to join Khronos and help us figure this out. So next API is ANARI, Analytic Rendering Interface. It's a fairly new API. It shipped in 2023. Its origin story is in scientific visualization. Classic fragmentation, where you have multiple visualization applications wanting to reach into multiple renderers. Every renderer has a proprietary API. ANARI provides a single API to access all of the renderers in a cross-platform portable way. The way that ANARI achieves that portability is it doesn't define how you're going to render a scene. It just lets you compose the scene in memory for the renderer to take that memory description and to render it however it wishes. So ANARI is defining not what, but when and how. So if you look at the stack, you have an application or a SIGGRAPH, an application using a SIGGRAPH, calling the ANARI API, going down into rendering engines, and the rendering engines themselves will then call down into the lower level APIs like Vulkan or DirectX. You already have a number of shipping implementations from AMD, Intel, NVIDIA, and there's more There's more coming. We just ran a hackathon just a few weeks ago for three days. It was a virtual hackathon, and we actually got some good work done. We actually overhauled the implementations of ANARI in some of the leading scientific visualization applications, and we added volume rendering to the Blender cycles renderer. There's quite a full-featured SDK for ANARI. Read it all out. The yellow text is where we've just had updates in the last few weeks, so that there's now a USD Hydra plugin for ANARI. That's the new Blender add-on. So we hope that Blender would make good use of ANARI because it will let Blender reach into many different renderers with just through one unified API. Debug layers have been updated, and there's we have an open source sample implementation called Helium, and that's just been updated. And he lied underneath it is implementation of wrong way around. Helium is a sample implementation. Helium is the set of components that you can use to create your own ANARI implementation. So there's a lot of we just had supercomputing in the US and off there, so there's a good amount of momentum building behind ANARI. And although its origin story is scientific visualization, ANARI is actually can be used by any kind of renderer and any kind of application. So we think for people that need that higher level access into rendering engines, ANARI is going to become increasingly interesting. Next, glTF and the 3D Commerce Working Group. So hands up, who here has heard of glTF? Those people. Okay, so glTF is a 3D asset format, and it's been designed for efficient transmission of 3D assets into any type of application, web applications, native applications, and it's a full-time job keeping this particular slide up to date as different engines and tools adopt the glTF format. We like to say glTF brings 3D everywhere. One of the very nice things about glTF, it has a very well and precisely defined physically based rendering model, the PBR model. And in the best spirit of standardization, we're not doing R&D, we're not creating new PBR techniques, but we're taking established practice from around the industry and capturing it in the glTF PBR spec in a very precise, well-defined way. So anyone who's creating engines and renderers and tools, can take glTF assets and display them in a very consistent way across different vendors. We're working on subsurface scattering that should be out in the next few months. But we're also reaching out into other standards groups that are working on material models. Material X, which is hosted at the Academy Software Foundation, is a material model that's been used up in the film industry for many years. And we're looking to export glTF into a Material X node graph. And we're beginning to look at how we can use Material X to drive procedural textures in glTF. So there's some good communication going on between those two communities. Also OpenPBR, which is a subset of Material X. We're working with that group to make sure that we're aligned. We're actually pretty close, but there are some differences, and we're working to close those gaps so we have smooth translation from one format to the other. glTF has a very active roadmap over the next few months. We're in the process of upgrading glTF from being a static single asset format into being a spatial computing format, or a metaverse format, if you want to use the M word. So we're adding interaction. So you'll be able to define a node-based graph, which defines interactions. You'll be able to reference multiple glTF files to create a complex scene with multiple glTF files. We're focusing in on complex scenes for the runtime use cases. We're not trying to duplicate what USD is doing up in the authoring space, but we're very focused on glTF's mission, which is runtime deployment. We are going to have a physics model for glTF. It's for rigid bodies. Again, not creating new ways of doing physics, but taking well-established, proven physics techniques that have been used for many years, but encapsulating it into the glTF format. And last but not least, audio, which will run off of the interaction graph, and you'll be able to set off 6 degrees of freedom audio along with interactions, so triggering, tightly integrated into the node graph. So taken as a whole, glTF assets become interactive, and interactive in a very portable way. Engines don't have to implement all of this new functionality, but if they wish to, they are able to do it in a very consistent way between different applications and platforms and engines. glTF2 is now an ISO standard. Khronos is one of 13 standards organizations in the world that's certified to make submissions to ISO for industry standards, and glTF 2.0 is our first submission. And that has created a lot of interest in using glTF, but in other standards. So, for example, the VRM avatar format, which is very well known here in Japan, and they're going to be part of our BOF on Friday. Iguchi-san and ANARI-san are going to be here talking, so please join us if you'd like to dive deeper into the VRM avatar format and how we're working together with Khronos to leverage glTF 2.0. In geospatial, the 3D tiles format is based on glTF 2.0, and PDF now supports glTF 2.0. So as the readers get upgraded, you'll be able to interact with your glTF models inside your PDF documents. We have the 3D Commerce Group, which is closely associated with the glTF working group. It is taking the glTF asset format and trying to do whatever we need to do to make it really reliable and robustly available across the industry. So we want to be able to build assets once and genuinely deploy them everywhere, and it works. So there's a lot of work, though, to make that happen in practice. So the key is put down on the bottom left is a validator. So any asset that is created, you can validate it to make sure that it's valid glTF. You have a sample viewer so you can view it. Asset library is the equivalent of the conformance tests for an API. We want to run the assets through all of the engines and players to make sure that it can handle all of the different features of glTF and all of the corner cases. We have an automatic asset generator to help us do that. And then last but not least, working with Google have been very generous and helping Khronos use the work that they've done previously to build a render showcase. So we can bring a glTF asset and display it in multiple engines interactively on the web in real time as a visual check that all of the engines are handling glTF assets consistently, and alerting everyone if there are differences that aren't intentional. So we can work with the engine vendors to make sure everything is being handled consistently. The three commerce working group has also been working on PBR neutral tone mapper. The tone mapper, as many people here I'm sure know, is vital to get consistent colors on the screen. It's actually quite interesting that all of the tone mappers, though, have been designed for movies or still images. There hasn't been a tone mapper for computer-generated images using PBR. And we found that PBR images were getting washed out in some of the highlights, some of the colors were not being accurately displayed. And again, Google, shout out to Emmett at Google, who did the heavy lift here, has defined a tone mapper precisely tuned to accurately displaying PBR generated models. And it's already getting widely adopted across the industry. It's been a need that no one realized we had until we solved it. So there's quite a heavy glTF roadmap. The light green is kind of what we've gone through. Some of the dark green topics that are in discussion. And again, we would love your input. If you have input, please get involved. Join Khronos, that's always the best solution. But all the glTF solution, development is in the open on GitHub. So you don't have to be a member. You can come to GitHub, look at the draft specifications, give us feedback, fix bugs in the existing specs. So some of the things we're looking at are advanced geometry, quads and subdivision surfaces. NeRFs and Gaussian splats are the hot topic of today. And there's a lot of discussion inside Khronos whether is glTF a good place to hold that, or do we need a standalone format for splats and NeRFs? There are potential advantages to having it combined in with the more traditional 3D geometry, because you can do hybrid use cases that need both. In which case, then maybe glTF can add value here. It's a very fast-moving area, so we think though during 2025 would probably be the right time frame for us to decide if and what glTF should do certainly for Gaussian splats and NeRFs maybe as well. There's the PBR roadmap continues to move forward. We're looking at diffuse transmission, and we're working even closer with Material X. We need a lot more work on animation, particularly for avatar animation. So we're looking forward to working with the VRM folks to together figure out what we need to do for much more sophisticated facial animation, for example, in avatars, different lighting models, and eventually, I think this is a longer term thing, upgrading our rigid body physics model into a deformable body physics model. But that's quite a big jump, and we need to be able to, anything we put into glTF, we need to make sure you can run on a mobile phone. So we can't move too fast because we disenfranchise the mobile platform. But we're monitoring all of this. Subdivision surfaces, for example, for a long time it was way too compute intensive for mobile, but now we think now that it's getting to the point where it's actually quite feasible. So, and it can help reduce the model size, which is great for your network transmission. So it's on mission. So we're looking at that, for example, very, very carefully. Quick shout out to the glTF and USD interoperability working group at the Metaverse Standards Forum. We're going to be talking about the Metaverse Standards Forum at one of the BOFs later in the week. It's not a standards organization, it's a place where all the standards organizations can come and meet and cooperate. And one example of that is that we have a working group there, which is imaginatively called the glTF USD 3D Asset Interoperability Working Group. And it's where the glTF folks and the USD folks come together. And we have really, I think, built a sense of community with the two different standards. It could have been a big competitive fight in the industry, but because we spent a year really getting to know each other before AOUSD, the Alliance for OpenUSD, launched at SIGGRAPH last year, the glTF folks are fully supportive, and we helped them launch, and with supportive comments and roadmap alignment. And we're working very closely as glTF is putting things in its roadmap, and USD is looking at the deployment end of its roadmap. We're trying very hard not to do things differently just for the sake of it. We're trying to align the two roadmaps so we can have easily transportable assets that can go in and out of USD and glTF in a very flexible way. And again, we'll be talking a lot more at the BOF. And actually, that's the end of my slides. I'm 5 minutes ahead of schedule. I can't believe it. So the glTF BOF. Oh, no, it's not quite. I've a little bit more. Okay, I'm going to be on time. Shot myself. So yeah, glTF BOF session. So if you want more about glTF, obviously that was a very high-level overview. It's on Friday at 11. We're going to have the VRM folks there. We're going to be talking about Metaverse Standards Forum, OpenUSD, the glTF roadmap. So please come if glTF is of interest. And then the last thing I want to mention is Khronos does have standards that are relevant to the web. We're definite believers in the web as a platform. WebGL, of course, is a Khronos standard, and it's about to be replaced by WebGPU, which is the new generation web standard. So WebGL was initiated and maintained by Khronos. WebGPU is a W3C standard, but that doesn't matter. We are fully supportive of WebGPU. It adds a lot more capability than WebGL, and we're doing everything we can, working closely with the W3C to make sure that developers have as smooth as possible transition from WebGL to WebGPU. But the web being what it is, as a platform, it tends to move slowly. And so this transition is going to take a few years at least. And WebGL, good news, is not going away. Khronos is busy supporting WebGL through this transition. We're actually adding new extensions to WebGL, but more importantly, just making sure that all the implementations are being properly tested. We're working on performance tests. And so WebGL is going to be there probably for decades, certainly as long as you need it. And Khronos is committed to making that so. And we are working closely with W3C. So WebGL was Khronos, but now we've got this pretty good model going where Khronos focuses on its expertise, which is the native layer, so Vulkan and OpenXR. And the W3C comes and creates the JavaScript level bindings into those native APIs. So WebGPU goes over Vulkan, not just Vulkan, but it's over Vulkan, the DX12 and Metal. But WebXR is essentially layered over OpenXR. Certainly the default backend for WebXR is OpenXR, and that lets them reach a whole bunch of different devices with one API. And we welcome very much that ongoing cooperation. In fact, the cooperation across the industry is getting stronger. I mentioned the Metaverse Standards Forum. We're working with AUSD, W3C, and ASWF. And on Friday, this BOF, whichever it is, Wednesday, tomorrow, we have this BOF where we're bringing all of those folks together. We have representatives from the ASWF, W3C, of course, the Khronos group. We actually have Mr. Doob here in person, going to be talking at the BOF. He's the maintainer of the 3JS 3D engine. We're going to be talking about latest updates on everything they're doing and how we're working together. So that is the end of my time. So now hand over to Ralph.
Thank you, Neil. Okay, so good afternoon, everyone. My name is Ralph Potter. I'm Samsung's primary representative with Khronos, and since September, it's been my honor to have been elected as the Vulkan Working Group Chair. So I'd like to start with an announcement. At SIGGRAPH Asia this year, we are announcing the release of Vulkan 1.4. I'll share a little bit about that today, but there'll be more detail at our BOF event at 3:30 on Thursday. More details on that will be on the final slide. So in terms of launch, the spec is out, the headers are out. NVIDIA have drivers out. The Mesa open source guys have drivers out for a bunch of hardware. So you can pick it up and use it today, which, given that we launched it at 2 a.m. this morning, is pretty good going. So what is Vulkan? It's a modern low overhead graphics API. It's the only modern graphics API that's available across Windows, Linux, Android, along with embedded devices and some consoles. It spans hardware from embedded devices like set-top boxes, through mobile handsets and portable gaming devices, all the way up to powerful desktop and server class GPUs. Again, there's no other API that has that breadth of coverage. So from the beginning, Vulkan has been driven by the needs of our users with input from game developers and other expert users in the industry. Over the past few years, we've evolved that process further. So hardware roadmaps are typically many years long. And if we want to evolve the API to meet the needs of our users, then that means that we need individual hardware vendors to make changes to their hardware. And we have to give them plenty of notice of that, which means that we need to be agreeing our requirements for the API today for things that might ship in 2028 or 2030. So we're working on that. This is a major strength for Khronos. There's no other place where all the other major GPU vendors are present and so many of the important content developers are in the room and able to hold discussions about what we need to do to enable that. So since Vulkan launched Vulkan has been launching core versions of the API roughly every 2 years since the launch of Vulkan 1.0 in 2016. And for Vulkan 1.1 and 1.2 in particular, we had functionality we wanted to include in the core API that not everyone could support. So we made those features optional. And that really wasn't very helpful for application developers. Having optional functionality in the core API isn't really any better than having optional extensions outside the core API. And so when we worked on Vulkan 1.3 in 2022, we took a different approach. And we said that core API releases would be about supporting functionality for the broadest possible set of hardware, and that new functionality should be mandatory wherever it was possible to do so. But hardware vendors still want to ship new hardware. They still have exciting new things that they want to share with developers. And so at the same time, we began defining what we call roadmap milestones. And those describe the set of functionality that all of the GPU vendors expect to ship on at least one device in the named year. So in that way, the roadmap milestones are describing the functionality of the latest hardware, and the core API releases are describing the functionality of the broad ecosystem of GPUs that exist out in the marketplace. So in 2022, we released a roadmap alongside 1.4. And then for 1.4, this is the first core release where we've been able to look at our previous roadmaps and pull them into 1.4 and say the things that were brand new in 2022, or maybe even the things that were new in January of 24, well, now we can put them in core. So I referred to a lot of this on the previous slide. Vulkan 1.4 is the first release where we've really seen the benefits of doing this. So our process for developing 1.4 was essentially to survey what existed in the roadmap profiles from 2022 and 24, the things that described high-end hardware, look at what we couldn't fit onto GPUs that describe the actual marketplace today. So maybe that's older hardware, maybe that's smaller things like SoCs that didn't fit all of the functionality. Take out the pieces that don't fit, and then everything else goes into core. And this has been a much smoother process for us. The hardware vendors had already agreed what was on the roadmap. They knew what was coming. They'd implemented their drivers. They shipped them and tested them. And because of that, even though we originally planned to ship Vulkan 1.4 next year, we found that we were ahead of schedule. The process has improved and helped us. And so we can ship it today instead of shipping it next year. So I don't have time today to cover everything that's in the 1.4 core. If you come to our BOF, I'll cover more of it, although I still won't have time to cover everything. But I'd like to talk about a few things that are kind of big and important in there. The first one is, for the first time in 9 years of Vulkan being an API shipped by Khronos, we've had an opportunity to raise the minimum bar for hardware requirements. We've never done that before. Vulkan 1.3 would have run on the same hardware that you could have bought in 2014 as a GLES 3.1 device. Today, we have raised the minimums, and we've done that because all of the vendors have been able to collaborate on a roadmap and agree where we were going. We were also told by developers that streaming images to the GPU without stalling rendering was an important problem to solve. So we have a solution to that. ext host image copy allows you to do that from the CPU side. And we couldn't make that mandatory for all hardware, but what we were able to do was say, either all hardware will support host image copies on the CPU, or it will have dedicated transfer queues that are asynchronous and will not interrupt your rendering. So there is a solution one way or another to do that. We also have much more fine-grained control of floating point optimization behavior. Now that's important both for performance reasons, if you want fast math, and also for correctness, if you want very precise behavior from your optimizations. And a final one that's important to me as somebody who works for a mobile vendor, making the dynamic rendering local read extension core makes it possible to use the very popular, much simpler to use dynamic rendering APIs on mobile without giving up the benefits of tile-based renderers. So we have all the functionality of the old render pass APIs, but in a much more accessible form. So we also have a BOF. It's 3:30 on Thursday in room G407. I will talk more about the 1.4 launch and what's in there. Spencer Fricky will talk about the Vulkan SDK update. We've also got talks on HDR support in Vulkan, GPU-driven rendering, and a talk on safety-critical Vulkan. So I'll just leave that slide up for a second and then hand over for OpenXR. Or is it Shannon next? That's Slang? It is Slang. It's Shannon.
Hey everybody, I am Shannon Woods. I'm the working group chair for the newly accepted Slang working group at Khronos, and I'm thrilled to be joining the other folks here for Fast Forward and to share with you all a little bit more about Slang. So just a few weeks ago, Khronos announced that it's going to be hosting the Slang open source shading language and compiler, which builds on 15 years of development at NVIDIA. Slang complements existing shading languages with modular code development, portable deployment to multiple target APIs, and support for neural computation. It makes shader compilation a one-stop shop for reaching the platforms you care about, and provides a modern shading language innovations to enable you to do things that you couldn't before. Slang and Khronos were a natural fit. The ecosystem has been in need of a modern, responsive, domain-specific shading language, and that is what Slang provides. Coming into Khronos open governance will foster industry-wide collaboration and make sure that language truly serves the needs of the ecosystem as a whole. But beyond that, the Slang initiative is built to be entirely for developers by developers. Any company or individual can become a contributor, not just Khronos members. And we do all of our technical decision-making in the open. The conversations between Slang's developers and the language creators and the users of Slang are happening right now on Discord, and you can join them. The decisions about what goes into the language are made by the developers of Slang, and the door is open for you to become one. I mentioned modern shading language features, and of all of the modern features that Slang offers, if I have to single just one out to talk about in my very short time here, it would be automatic differentiation as a first-class language feature. That is the headline. It makes it ideal for easily integrating neural computation into graphics shaders. Slang can automatically generate both forward and backward derivative propagation code to make rendering code bases differentiable. The ability to embed AI inferencing and training directly into graphics applications will enable significant new rendering use cases. And since we made the Slang announcement just like a week and a half ago, I think, interest in the project has really taken off. We're now at 3,175 stars on GitHub. We're actually probably at more because that was from when I checked a couple hours ago. And it's still climbing. We've been having some great questions and thoughtful proposals come in through all of our collaboration channels. So we think that this is just the beginning. There is a lot more detail to be had about Slang. Its rich feature set, how to bring your code over to Slang, and all of the resources that are available for you to access. And I'll be talking about all of that at tomorrow's Slang Birds of a Feather session at 1:00 p.m., also in room G407. So I hope that you'll be able to join us, and I hope that I see all of y'all out there in the Slang community. And now I think it gets to be turned over to OpenXR.
Thank you, Shannon. Yeah, everyone. My name is Zhang. I'm from PICO. Today I'm going to give a quick fast forward update on behalf of OpenXR work group. So first, what is OpenXR? So of course, OpenXR is the open standard for XR, right? It provides a common set of API for XR applications that run across a wide range of XR devices. The standard has been widely adopted by the XR industry, and it has already significantly transformed the landscape of XR application development. Here we have a before and after diagram. So before OpenXR, applications, games, and engines have to juggle different codes for each platform or devices. OpenXR simplifies this process to make life easier for both developers and hardware vendors. It fosters a unified application ecosystem and also help the adoption of the XR applications. So we have wide support across a lot of different devices, not just XR headsets, also 3D displays, simulators, and development platforms. So you can be certain that the majority of XR products support or will be compatible with OpenXR. So since the formation of the OpenXR work group in 2017, we have achieved several significant milestones, including the release of OpenXR 1.0 in 2019 and the release of the OpenXR 1.1 in April of this year. There are many important updates in OpenXR 1.1 spec, and we're not going to go through them. And here, just a few quick examples there. For example, local floor reference space, so which is similar with the original local space, but with floor height built in. So this is much more convenient to users and developers, make the calibration process easier. And the grip surface allow applications to reliably render a virtual object held in user's hand. And another one is because the stereo forwarded rendering extensions, which enabled a hardware-independent way to enable forwarded rendering, so which is portable between different API and hardwares. And also there's much more update. So there are also numerous new extensions coming soon, including improved hand full body tracking, spatial anchors, enhanced haptic support, and glTF support for render models. So we can finally have a future approved way to have to render the new controllers, right? So we don't have to rebuild the app for each time the new controller came out. So for more details, please refer to our specification and the GitHub repository. So we also have a Bob session, and where we will give an update OpenXR workgroup progress and future roadmaps, which will be a little bit more detailed than this fast forward. And also, PICO will share 2 talks and explore 2 directions. And one is enabling multi-application support in XR. The session will focus on key topics such as multi-application support, also a comparison between different rendering architecture, we call it self-rendering versus unified rendering. Also, the next step for advancing the open standard for that. Another topic will be secured and private access to XR device camera and sensor data. And the presenters will introduce a privacy-focused system that enable developers to run their own MR models directly on the XR device, ensuring the sensitive camera data remain unsecure and is not shared with the application. So we look forward to your participation and engage discussions. Okay, we'll see you at our Bob sessions this Tuesday, 2 p.m. and 15. So then we'll have Neil back for the Q&A session.
Great. Thank you. So, before anything else, a big thank you to all the speakers. It's a lot of late hour nights have been put into getting this slide deck for you. So, we have almost 15 minutes. So, open it up to any questions. We have all the speakers here. So, ask questions on any of the topics that we've covered during the past four. We have microphones, so any questions? So I have one to kick one off. A question for Ralph. You know what it's going to be. Vulkan video. How's that doing? Do you want to? Because we had some recent announcements on that too, right? With the AV1.
Yep.
Mike.
Oh, sorry.
Yes. Are we on?
Yes.
Yeah. Okay. Yeah. So Vulkan video has actually been really busy this year. So the AV1 encode extension was released last month, I believe, along with the quantization map extension. I believe the last piece of the puzzle still to come is VP9, which is in flight. So yeah, been very busy, very productive. Yeah, I'm really pleased with how Vulkan video's going.
Yeah, I think AV1 encode has been the one that everyone has been really.
There's been a lot of questions about when that was coming, and it's here. So yeah.
Okay, and whilst we're thinking of the questions, the link here, if you haven't mentioned it before, is the link to the Khronos page where you have all of the BOF information, so you can go and find out what Khronos is doing, and the timetable is up there. Any other questions? Yeah, easy. 1, 2. Okay, we'll get to you.
I have a question about Slang. So in my previous work, I was converting HLSL to metal language by using HLSL to SPIR-V and then using SPIR-V cross to MSL. And while this is mostly the job, when using the debugger, the graphics debugger, the metal language like loses variable names and stuff, so we have to kind of deobfuscate the code manually by hand. And is this something that Slang improves on during the conversion?
Massively. So I'll talk about this a lot more in our BOF session tomorrow. But Slang preserves identifier names. It includes line directives in its output code in order to make human readable and very debuggable code. So this is a high priority for Slang. And the intent is definitely that what comes out should be as understandable as what went in. You can actually take a look at the metal that gets generated right now. We have on our website, which you can get to from the Khronos website, there's a shader, a Slang playground. So you can actually see the metal that Slang outputs and how similar it is in structure and naming to the original.
Thank you very much.
Thank you. There's a question over here.
Yeah, so I saw that you had listed OpenGL in the active standards slide. Has there been any developments in recent years?
I think you take it.
So OpenGL, just like WebGL, is going to be around probably longer than I am going to be here. So again, it's a key mission for Khronos to make sure that OpenGL is fully supported. So the working group actually meets regularly. It's developing new conformance tests. And so it is being developed and supported for any developers that want to use it. It is true, though, that new generation of functionality is no longer being built into OpenGL. We're focused new functionality into the Vulkan roadmap now, because that is the modern API. But no, OpenGL is an important message. Thank you for the question. The important message: OpenGL is not going anywhere, but it's not going to take on the new functionality that Vulkan is taking on. Thanks. Other questions? Yeah.
So I was also wondering if those the 5 APIs are also available on an embedded system as well. Like I was always using OpenGL ES for the embedded system, so I was wondering if those other 5 APIs are also available on those systems as well.
Yes, I think in general most of them are. Of course, Vulkan definitely is. OpenCL definitely is available in embedded and mobile systems. OpenVX is. So yeah, I think that's the full set. I think one of the values, of course, of an open standard API, whichever one it is that it can be deployed on multiple platforms, multiple operating systems, multiple price points, multiple markets. Whereas some of the proprietary APIs that they're also awesome, but they're typically focused on a particular platform. But Vulkan's value, I think, to the industry is that it can be deployed everywhere. And as part of that, yes, I think pretty much all the APIs are available in the embedded space, and many of them are in mobile as well as desktop. And of course, the cloud, Linux, runs a lot of the cloud, and the Khronos APIs are really effectively the native APIs for the Linux OS. So the Khronos APIs are in a lot of different platforms.
Thank you.
Okay, any other questions? If not, we can. Oh, Takashi-san, do you want to mention that? Oh, what? Go ahead.
まず日本語でちょっとご説明いたします。 金曜日の3時から夜の7時にかけて、クロノスグループの方でブリーフィングとネットワーキングのレセプションを招待制で予定しております。で、私が持っているこちらのカードなんですけど、maybe I'd better go in front.
And you have to do it in English too.
Yes. このカードをお手しした方は裏に QR コードがあるので、そちらの方からご参加いただければと思います。Next is English. So for everyone attending this session, have you received this small card? It has information about briefing and networking reception of Khronos Group, which happens on Friday, 3 p.m. to 7 p.m. And it's invitation only. And if you want to join us, you need to register from this QR code printed on the backside. And those cards should be available from me or
Lucy, yeah, any of us.
so,
Like one of us, yeah.
yeah, if you're interested.
Yes, thank you for reminding me. Okay. You didn't know it, but by being here, you are now VIPs. So you now have an exclusive invitation to the Friday. Please register just so we know how much food to make. It's free. You don't need a SIGGRAPH badge, but it's just a way for us to get to have more time with folks who want to know about the Khronos work. So we're happy to see you there if you want to join us. And it's in a venue that's a couple of minutes walk away. Right? It's very close. So. Okay, any other questions? I think we'll call it there. Thank you again to all the speakers, and thank you for being here.